So please join me in congratulating Fritz and Paul Clacy as Minister Award winners.
One of the highlights of the Premier Summit on Agri-Food at Queen's Park in March 2007 was the presentation of the first ever Minister's Award for Agri-Food Innovation Excellence to two brothers from Cobden, Ontario, two modern-day pioneers in the on-farm generation of electricity. When Paul and Fritz Clacy came to Canada from Switzerland in 1990, they brought with them the technical know-how to explore the frontiers of green energy. As dairy farmers milking 140 cows, producing a total of 6,000 cubic meters of manure every year, they already knew they would have the raw material. The Clacys started out with a generation system largely of their own design, incorporating biogas technology from Germany, adapted to Canadian conditions. The rubberized dome that covers their manure digester would fill up at least 3 times a day with 150 cubic meters of methane that they burned in a generator to produce as much as 750 kilowatts of electricity, enough to power the farm, as well as heat to supplement their hot water tank. And, through a net metering agreement with Hydro Ontario, even a modest reduction in their own electric bills.
So the manure was able to supply all the electrical needs of the farm, which is about equal of about 20 to 30 houses average in Ontario.
Adopting the latest in biogas technology, they've already increased their output by 300%, with the hopes of tripling that yet again, generating a continuous 500 kilowatts, enough to power almost 500 energy-efficient homes. To achieve this, they've drawn on the expertise of companies like Genesis Biogas, a new engineering firm hired to help them develop the pasteurization unit and the control system. What made such an impressive increase in production possible are changes to the Nutrient Management Act to allow farms to take in certain low-risk, off-farm materials to be co-digested with manure and other farm wastes.
So we have set the criteria, we've set upper limits of a farm can only take up to 25% off-farm materials. 50% of the material that the farm contributes must be manure, and there's an upper limit of 5,000 tons per year of material you can take.
Now, once every 2 weeks, a truck pulls up to the Clacy farm with a slurry of restaurant food waste to mix into the manure in their digester. It's a little-known fact that almost every restaurant in every community in Ontario, in fact, all over North America, has what's called a grease trap to divert and capture the food wastes that otherwise go down the drain, and which they're required to have pumped out and hauled away.
Grease traps or grease interceptors in food service facilities are collecting the sanitary stream from the kitchen, from the dishwasher, from all of the sinks, and intercepting and collecting the fats, oils, and greases and food waste materials that are there so that they do not enter into the downstream collection network and the sewer pipes and the lift stations and ultimately the wastewater treatment facility.
These materials are challenging to treat in a wastewater plant due to their high organic loading.
In addition to the grease trap wastes and the fats, oils, and greases, there's a growing stream of organic vegetable materials from grocery stores and other food service facilities.
This is a great material that we're using here. For example, grease trap waste, it's loaded full of energy, so we can take it out to the farm, we blend it with manure, and you get a very large yield of biogas from that, which then can be run through a generator to produce electricity.
However, the use of off-farm composting materials is, without question, another form of waste disposal, and as such, subject to Ministry of Environment regulation.
Both the Ministry of Environment and the Ministry of Agriculture, Food and Rural Affairs have been working together to help the farmers and reduce the regulatory burdens. One way that they're doing this is by amending the Nutrient Management Act. And with these amendments, there are reduced requirements for certificates of approval if they're bringing on off-farm waste to their site, and as such, there's less regulatory requirements. Although the regulatory requirements have been reduced, there are still safeguards in place to protect both the public and the environment.
One of those safeguards is the installation of a pasteurizer to treat the food waste to ensure that once the energy has been removed, the effluent from the digester can be safely spread as fertilizer.
This pasteurizer, what it does is effectively treats the materials at 70 degrees Celsius for a guaranteed 1 hour period, and that will have a 99% pathogen reduction in the process.
The Clazy brothers and Genesis Biogas developed and installed the pasteurizer and its automation system to ensure safe and continuous digester feeding. Genesis was also actively involved in the sourcing and testing of off-farm material to ensure its suitability for the digestion process. Regular testing of the digestate is standard operating procedure at the Clazy farm. The University of Guelph's Alfred College has coordinated the testing of Clazy's manure, as well as conducting additional research on the digestion process. Results are given to Genesis Biogas engineers in order to optimize system performance. This research accelerates innovation in the use of different feedstocks.
The manure effluent is almost unchanged. You can smell a difference, and also the samples we see have not changed significantly. So I think it's a great process to add to a farm.
Necessity being the mother of invention, the Clazy's tripling of their biogas production necessitated an increase in generating capacity, in turn made possible by the installation of this prototype containerized generating unit manufactured by Powerbase in nearby Carleton Place.
This is a standard ISO shipping container, 20 feet long, and what it contains is the entire power generation and control system. So behind me you see a modified 8.3 liter engine which is designed now to burn biogas. The engine then is connected up to what's called a brushless alternator, which produces electricity, which can then be fed through our control cabinets, special metering, and then out onto the provincial electrical grid. A second control cabinet located inside the unit also does all of the monitoring of the system and connection onto the grid, electrical power protection, and so on. We also have in the piping that you see in the building collects the waste heat from the exhaust stream of the engine as well as from the block, and then we take that heat and put it into water, which is then pumped throughout the farm operation for operating the digester, heating houses, crop drying, production of hot water in the dairy process, and other applications where hot water is needed.
And the Powerbase unit is chock full of safety controls and monitors.
We've got everything in here from heat detection, fire detection, methane leakage, electrical power issues from faults being over voltage, under voltage, and all the requirements of the Ontario distribution code. So the system is very, very carefully designed and designed to shut itself down in the event of any sort of an emergency.
Whether it be a fuel tank, whether it be a propane tank, whether it be a digester that has methane in it, there is a risk that you must properly manage. There will be a methane monitor to make sure that if the methane level gets too high, an alarm will go off or a fan will start to ventilate the process. You need to have proper setbacks from combustible buildings to ensure that if you did have a fire in, say, one component, there's no probability of this fire spreading. When you hook into the grid, the Hydro One will be ensuring that you got proper connection procedures to maintain safety for their workers on the grid.
Environmental safety is important too. Methane, after all, is a greenhouse gas. The Clazys worked with Genesis Biogas and the Ontario Ministry of Agriculture, Food and Rural Affairs to develop a farm-sized flare system.
Right now, because of limits to the line, they cannot fully utilize all the methane or all the biogas that is being produced. So they have installed a flare. And so what the flare does is that greatly reduces the greenhouse gas emission by combusting those materials.
As well, the Ministry of Agriculture, Food and Rural Affairs has provided financial support for farmers, food processors, municipalities and other businesses with a viable plan to generate biogas to help kickstart this fledgling industry. Now, there's also a biogas association for farmers and other members of the agri-food sector, the Agri-Energy Producers Association of Ontario, for sharing information and speaking as one voice to governments and organizations like the Ontario Federation of Agriculture.
We started an association in June 2007. We saw the need that to really group ourselves together because there are so many issues to deal with when you want to go through a process like we did.
As well, the Agri-Energy Producers Association now belongs to the Ontario Sustainable Energy Association, and interest is running high in the Clazy's new system, with at least 2 groups a week visiting their farm to check it out.
With so much interest there, it's actually really encouraging that we could hopefully see many projects being completed and hopefully coming on stream within the next couple of years.
Some foresee the day when hundreds of small generating facilities in Ontario, like the Clazy Farm, might generate enough electricity to power whole communities with hydro, heat, and automobile fuel. And in fact, that's all starting to evolve in Europe, where they're even looking to the day when cars may be filling up on compressed biogas produced on farm. It may not happen quickly. It's a very complicated business, and it may even take a generation to come to fruition. But the next generation will be ready and able.
This new program that they put in, a lot of it is similar to courses we have taken in school, and so to catch on it's easier, I guess, for the younger generation than for an older generation to see how these things work.
Based on results from their farm so far, the Clazys will be continuing to expand in the future. They've recently ordered a 500 kilowatt high-efficiency GE Jenbacher generator and will modify their digester to allow them to produce even more energy for the people of Ontario. The Clazys project's success and leadership has been an inspiration to many others in the province. One thing is probably certain. Along with wind and water and other different forms of renewable energy, biogas will play a significant role in the future of Ontario's rural community, sustainable agriculture, the health of our planet, and the future of our children.